Should probably hit record. So Cartesian sounds pretty fancy, but really it's not. What is a Cartesian plane? Nobody knows? Cartesian plane is just the XY coordinate system you're used to working with. That's all it is. It's a big fancy word for a graph, the kind of graph that you're used to using. When we graph, what axis is the horizontal axis? X, that's right. What is the vertical axis? Y. So when you plot points in a coordinate plane, they have two parts, right? An X and a Y. How do you plot in the coordinate plane? Do y'all know how to plot points in the coordinate plane? Yeah. Yes. Rise over run. That's exactly right. So if I asked you to plot the point 2, 1, tell me what you do. You got to go over 2 because this is your X, and up 1 because this is your Y. So this is the point 2, 1. And I know that seems really basic, but even at this level, we tend to get them confused sometimes. We'll go over 1, up 2. Yeah. I do actually. Plotting any value. What if I wanted to plot the point -1, -4? What do I do?
I said you better go left 4.
To the left 1, that's right.
Oh, you said -1.
And down 4. Yep.
You said -4.
What is, am I going too fast? Okay. What is this point in the middle called? Origin. What are the coordinates of the origin? 0, 0. That is exactly right. All right, so sometimes we have a big set of data and we graph it on a coordinate plane. What do we call it when we have a whole bunch of data and we plot it on the coordinate plane? Do you know? Starts with an S. Yes, a scatter plot. Let's say, and I'm just going to grab this example out of your book. If we had the year versus the amount of money in U.S. exports. This is just example 1 in your book. And so let's go 2000, 2001, and we'll take it all the way to 2007. 4, 5, 6, and 7. This is in billions of dollars, by the way. 101.3, 97.5, 97.4, 110.8, 120.4, 134, and 136. So when I plot this, or when I graph this in a coordinate system and I graph a scatter plot, how do I know what to graph? What is what here? What generally goes on your x-axis? Time. That's right. Time. So this is going to be my year here, which means this is going to be my exports. Uh-oh. All right, I know some of y'all are still copying there, but let's see. I need to get up to, what, about 140, 135, 136? Oh, I think I can go by 10s on mine and I'll be good. So whatever you need to go by on yours, and then we'll work together and 50. Do y'all remember how to? These are more aggravating than they are hard, I think. They're just so tedious to create. 80, 90, 100, 10, 20, 30. So that would be 140 up at the very, very top. You got it? I'm going to go every other line here. I'm going to do this as 2000, 2001, just so you can kind of see. 2002, 2003, 2004, 2005. You didn't get your computer? 2006, 7. Oh, that's all we need is through 7. Let's plot them. Nothing to it but to do it. 111.3. Don't get caught up in trying to be exactly so precise because you're not going to be able to do that on something this size. I'm going to go just a little past 110. And then we got 2001 is 101. And 2002 is 97.5. This is really more practice graphing than it is anything else. But this allows us to see some trends and some things going on when we graph that we wouldn't see just looking at the set of data. 110, 120. 134, 136. So it's a lot easier to see here that it kind of dipped down and then it started to grow again and it's starting to even back off there in 2007, 2006. Do y'all have any questions about scatter plots? Because you'll have to do a few scatter plots in your homework. They're not really hard. I just gave you this set of data there in the corner. U.S. exports in billions of dollars. It was just an easy set of data as an example in your book, so that's what I used. Let's talk for just a minute about absolute value. That's always easy for most students. What is absolute value? Or what does it do? Makes it positive. The absolute value just means that at the end of the day, you make it positive. We also refer to absolute value as magnitude. And also as distance. Because we can't have a negative distance, right? So if we subtract, if we're looking at like distance on a number line, if you were between, say, let me just put a number line up here. -1 and, actually let's say this is -10, this is -1. If you subtract those two values, either way you do it. If you do -10 minus -1, you're going to get a negative number, but you can't have a negative distance. So what we do is we do the absolute value. So the distance between those two numbers is 9 units. Does that make sense? And you could count those and look at it, but we just keep absolute value because distance is always positive. Everybody good on that? I think with all the interruptions today, I am going to stop there